that when you write something down, it reinforces your memory of it.
Okay.
Okay?
Yeah, for sure. Yeah.
Do you have anything specific to work on tonight?
Yeah, my mom sent just like a quiz that I took a while back. She scanned it and then I think sent it to your email.
I have not
Um,
gotten it yet.
Not yet.
Well, while we're waiting for that,
Uh-huh.
in fact, this might be better to do.
Okay.
I am
Sure.
100% convinced this is going to cure your memory problems with geometry.
Okay,
I
cool.
just think by doing it and by using them,
Mm-hmm.
you will get it. Okay?
Okay.
Here's what I'd
Perfect.
like you to do. Do you have anything that's like a 3-inch by 5-inch index card, just white on both sides?
I think so, yeah. Do you want me
Uh,
to grab one real fast?
yeah, grab something. Yeah, I
Sure.
want you to make at least 8 of them.
Okay, so I'll just grab like a whole bunch of them.
Okay?
Alright, cool. Just give me a second.
Sure.
Okay. Okay, cool.
Okay. Now here's what I want you to do. On one side, I want you to write the name of the object.
Okay.
Be it circle or triangle or rectangle or square or whatever.
Sure. Okay.
I've got a list of the ones I want you to do. And
Okay.
it's mainly the 6 quadrilaterals you've been studying, which are
Okay.
rectangles, squares, parallelograms, rhombuses, kites, and trapezoids.
Uh-huh. Do you want me to draw it or just write it down?
Now, for the moment, you may have to review this thing
Okay.
because I want you to make a card for each of these things.
Okay.
And when you're done, I want you to show your mom that you've done so.
Okay.
And
Sure.
she can, or somebody, or you can do it by yourself even, but it's actually better if somebody else does it. And that's shuffle the cards up and show you one side or the other.
Okay.
You have to name
Sure.
the other side.
Okay. Yeah,
In
that
other
sounds
words,
good.
if you see circle, there's 2 really important things about a circle. Now,
Uh-huh.
that's what you put on one side. On the other, draw a picture of the object and don't label everything, but label the important things. In other words,
Okay.
if you're talking about a circle, there's really only one important thing, and that's its radius.
Okay.
Everything is a function of its radius. And the only 2 things there really are for circles are area and circumference. So
Okay.
let's make the other side of the card look something like this.
Yeah.
And
I just got that. Yeah.
what I want you to do is keep it as simplified as possible. We don't want a
Okay.
lot of sentences.
Mm-hmm. Sure.
Okay?
Okay.
So what would triangle look like? I'm gonna leave. What I'm gonna do is draw this.
Okay.
I want you to tell me, what do you think we should put in there? I'll draw the picture of it.
Okay. Sounds good.
And I'm going to label the base, and I'm going to label the height.
Okay.
It's the area of the triangle.
Base times height divided by 2.
1/2 base times height. I
Okay.
prefer to think of it like that. I don't know why.
Yeah.
I guess
Okay.
it's important to think of a triangle as being half of a rectangle.
For sure.
And a
Yeah.
rectangle is base times height. So rather than
Uh,
base times height divided by 2, I'd rather say it's 1/2 base times height.
okay.
You can do it however you want, but
Sure.
I
Yeah.
don't know of anything else we need to know about a triangle. That you need to know.
Volume,
In
maybe?
other words, the what?
Volume.
Not for triangle. A triangle is a two-dimensional object that doesn't have volume. It only has area.
Okay.
In other
Cool.
words,
Yeah.
it's like a circle only has area, but a sphere has volume.
Okay.
Okay? So if I
Sure.
turn this into a prism,
Then
yes,
you can do volume.
then it would have volume. Yeah, if I made it into a three-dimensional prism. Okay?
Okay.
So
Awesome.
let's just kind of spend tonight going over each of these and figuring out what we want to put in there.
Okay.
Now, let's jump ahead to a moment and do rhombus.
Okay. So
Just because that's what I was thinking.
the rhombus, like the rhombus right now.
Yeah, what would you want to, first of all, the drawing of it. What am I going to do?
So for the rhombus, it looks like, well, it's a parallelogram.
Perfect. That's what I wanted to hear out of you.
Okay, cool.
So we're going to draw it like a parallelogram. But it's
Sure.
a special kind of parallelogram. What's
Okay.
special about it?
That, like, the opposites, well,
No, the most important thing, the number one thing you want to put down here.
it's a quadrilateral.
No?
All sides are congruent to each other.
Let's just say they're equal. And I'm
Or are
going to
equal.
say that only because it's shorter than the word congruent. I want
Sure.
to keep as little words as possible over there.
Okay.
Now, if I want to make it a little bit more clear, I can put a hash mark on all four. Now I've said that same statement twice.
Okay. Awesome.
Okay? Now, what else do we know about a rhombus? All sides are equal.
We know that.
We know about the diagonals.
Yeah, the diagonals
We
by.
know about angles.
Okay.
In other words, we know stuff about angles, we know stuff about diagonals, and we know that opposite sides are parallel.
Okay.
We should put all four of those things.
Sure.
Because that's the only things that really matter. And maybe the area.
The area, yeah.
What's
and
the
then,
area? In other words, I think you probably want to put the area of each one of these figures.
Okay.
Okay.
Sure.
But
Yeah.
now, I jumped to rhombus for a reason. Some of this stuff's going to apply to a parallelogram. Now, when you draw the parallelogram, you're going to want to draw it elongated a little bit so that it does not look like a rhombus.
Okay.
Okay?
Okay.
Just saying. In other words,
Yeah.
these are both parallelograms, but only this is a rhombus. This is only a parallelogram.
That makes sense, yeah.
Okay?
Okay.
Now, what's the second thing about rhombuses? Besides all four sides are equal. What do we know about angles?
Well, we know that the angles, like the opposite angles, are congruent to each other, equal to each other.
Opposite angles are equal, and opposite sides are parallel.
Yeah.
And I could say that it's a parallelogram, but that might be a little confusing because you're going to be looking at this side trying to figure out what's the name of this object. So I'd rather not say it's a parallelogram. But let's say opposite angles are equal.
Okay. That makes sense.
Notice only opposite, not all.
Okay.
In other words, this one is equal to that one, and that one is equal to that one.
Okay. Yeah, opposite angles.
And
okay.
Opposite sides are parallel.
Okay.
That's another important feature. Like I said, I could say that in a couple of ways. I could say it's a parallelogram, but I'd rather say it like this. Because that's kind of the definition of parallelogram. In other words,
for sure.
one of the things we're going to put up here is that opposite sides are parallel.
Okay.
And maybe we want to use the parallel sign instead of spelling it out, just to keep it shorter.
Sure.
And
Yeah,
in fact, I could use the equal sign instead of spelling it out. I want this to be as cryptic as possible. I don't want you to have to read a lot. I want you to be able to know what each line means quickly.
Just like short and brief, yeah.
Yeah, short as you can get.
Okay, cool.
Now, there is a fourth thing, actually a fifth thing, with rhombus. So some of these things are going to have more than just two important things, like a triangle. There's two very more important things about a rhombus.
Okay.
Besides what we've listed, and it has to do with the diagonals. And the clue is I drew the diagonals on there.
Yeah, I was gonna say the diagonals are perpendicular to each other.
Okay.
Are perpendicular.
Diagonals are perpendicular.
Uh-huh.
What else?
They bisect each other.
That's the last thing.
Okay.
The diags bisect each other.
Okay.
So, after you make these cards and you use them for a while, if one side says rhombus, you're going to remember all five of these things and know how to draw one.
Okay, cool.
And if you're looking at this side that shows you all five things and a diagram of it, you want to be able to name it.
Okay, cool.
Okay?
Awesome.
Now, let's go back to parallelogram and see how parallelogram is going to differ from a rhombus. First of all, our drawing is going to be a little different.
Okay.
Right?
Further wrong. Okay.
We're going to still put the diagonals on there.
Okay.
Because there is a relationship with the diagonals. Besides the opposite sides being parallel, what else is true about opposite things?
Well, let's see. The opposite angles
are
congruent to each other, or equal.
I think I'll spell out equal rather than put the equal sign. You don't want confusing things.
Okay.
Are the diagonals perpendicular?
They're not, because they don't form 90 degrees, yeah.
Exactly. But they do bisect one another.
They do, yeah.
So the diags bisect.
Okay.
Now, is there anything else bisect one another? Certainly, adjacent angles are supplementary, but we can kind of figure that out. In other words, once we know the opposite sides are parallel, then I basically have two parallel lines with a transversal, right? So I know that adjacent sides are the same adjacent sides as you would have with two parallel lines and a transversal, adjacent angles rather, and they must be supplementary. So there are other things that you can figure out that you don't necessarily have to put on the card.
Okay.
But you want to, I think, put a minimum of the stuff that we'll go through tonight and put on these things. And rather than making the card as we talk, because I may think of something else, a sixth thing that needs to be on here, perhaps you want to just help me go through the things tonight, and then if you need to, watch a recording of this thing to figure out how to do it.
Yeah.
Or try to do it from memory and then compare it to this recording and see if you forgot anything.
Okay.
Okay? So let's do rectangle. And I'm not putting them next to one another because this would be kind of a cool question. Which of these rectangles goes with which of these things?
That would be kind of like matching.
Yeah, exactly. So I'm almost purposefully not putting them in order.
Okay.
Now for a rectangle, what's important to have on there?
We could area, well, it's basically self-explanatory.
Well, not really. No, let's put some things. I think area is a good one because that's base times height. That's one of the
Uh-huh.
important formulas in geometry.
Yeah, for sure.
And in fact, for parallelogram, I might want to put area is base times height. But what's the difference between parallelogram? In other words, when I say a parallelogram is base times height, I mean vertical height,
Okay, well,
not slant height. So
okay.
perhaps my parallelogram needs that and labeled H.
Okay.
Maybe I want to put area equals base times height on the parallelogram also. But by drawing a vertical slant height, you make it apparent that it's not a horizontal slant height.
It isn't, no.
Yeah, I mean, maybe you get a parallelogram that's labeled like that, 5, 6. Well, the area is not 30.
No, it's not.
So you got to be a little bit careful about the height you use on parallelograms.
Okay.
Same thing with rhombuses. But so the only reason I'm putting it in for a rectangle is because there's not much else that we need. What's the only other thing about a rectangle? Well, then.
Well, we could say the opposite sides are perpendicular.
Not perpendicular.
Or,
The opposite
equal 90
sides
degrees.
are what?
Are, adjacent.
Well, there are two things the opposite sides are.
They're 90 degrees.
No, hold on. Don't get angles and sides mixed up.
Oh, whoops, yeah.
They are separate things, okay?
Uh-huh.
So, what are the opposite sides? There are two things.
They're supplementary.
They're parallel.
Sides are parallel, yeah.
Right? That side's parallel with this side, and that side is parallel with this side. And equal.
And equal, okay.
Right?
Okay.
And the only other thing we need is all angles are what?
Congruent.
Or 90 degrees.
Just 90 degrees, okay.
They're all right angles. If you prefer, all angles are right.
Okay.
But I like 90 degrees better.
Yeah,
okay? And that's all we need to know about a rectangle. That tells everything you need to know about a rectangle. I mean, it doesn't tell you the perimeter, but perimeter's not hard. You're not going to forget perimeter. Perimeter is 2 bases plus 2 h's. Right? Perimeter being the area around the thing. And I didn't put perimeter up here either because perimeter is the same regardless. It's each measurement of all the sides. Added up.
Yeah.
Okay. Square is probably the easiest one to do.
Let's do that.
Now, a square is also a rectangle, right?
It could be, yeah.
Well, it is one.
It is, okay.
It is, which means everything that applies to my rectangle is going to apply to the square. So I don't necessarily think you have to repeat everything up here.
No.
You know that the square opposite sides are equal and parallel. Every angle is 90 degrees. There's only one additional thing the square has that the rectangle does not.
All angles are equal.
All sides. All
sides are equal.
All angles are equal also.
Yeah.
But all sides are equal.
Okay.
That's summing it up. I'm not worried about you not knowing a square's properties.
Awesome. Yeah, it's pretty simple.
Yeah, the square and the rectangle are what's simple. What's harder are the rhombuses, the kites, the trapezoids, and the parallelograms.
Yeah,
so,
definitely.
See if we can figure out. And we've done circle, triangle, rectangle, square, and rhombus.
And
And we've got
parallelogram.
parallelogram. So let's do kite and trapezoid.
Cool.
Kite,
Let's see. So, yeah, there we go.
draw it.
Yeah.
Draw it exaggerated. In other words, I could also draw a kite like this. That's a kite also. It's a diamond, but it's a kite. Okay?
Yeah.
But that's a special kind of kite. This is a typical kite.
Okay.
And one of the most important things about a kite is that side's equal to that side, and those sides are equal.
Okay.
So by drawing that in the picture, you don't have to spend a sentence and a half spelling it out.
No.
A pair of adjacent sides, I don't know. Maybe you don't need to say anything. What's important about the kite is the diagonals.
The diagonals. Wouldn't they be perpendicular?
Okay, that's good. The diags. You know what? Let's start with the area, because we're putting area at the top. Let's be consistent here.
Okay.
In other words, in this one we put area right there. At the circles and triangles we put area at the top. We're going to want to know the area of this kite for sure.
Okay.
That's definitely one.
Yeah.
What's the area?
Would it be...
A function of the diagonals.
So would it be base times height still? Or
No, don't call them base times height. Call them diagonal 1 times diagonal 2.
Oh, okay, so like D1 times D2.
Yeah. But is it D1 times D2, or is it half of that?
Would it be D1 times D2 divided by 2?
Uh-huh. It's half.
Okay.
Okay. And that's a dot. Make sure you know that's multiplication.
Yeah.
And the diagonals are perpendicular, which they are only on a few of these things, are they? They're perpendicular on squares because a square is a rhombus. They're perpendicular on rhombuses. They're not perpendicular on regular rectangles, and they're not perpendicular on regular parallelograms.
No.
Okay, so there's only 3 of these figures where the diagonals are perpendiculars, and that's the bottom 3 that I have drawn here. And there's one fourth thing.
Okay.
Has to do with the diagonals and whether or not they bisect one another.
Okay. Well, they do bisect, but like they're not. It doesn't bisect into 2 equal halves.
One diagonal bisects the other, but only one.
The vertical one.
The long one.
Oh, the long one.
Huh? Notice the short diagonal does not bisect the long diagonal.
No.
But the long diagonal bisects the short. The long diagonal bisects the short diagonal.
Okay.
And I can't think of anything else that's important about a kite.
Me neither, yeah.
Other than the basic definition that you have to have 2 adjacent sides equal, and these 2 have to be equal. But rather than spell that out with 2 sentences, I'd rather just show it with the picture. Okay? And in other words, by drawing your picture kind of like I've drawn it here, becomes obvious when you look at it that this is a kite because this side's equal to this side and because this side's equal to this side.
Yeah.
Okay.
Okay. Awesome.
Now, 1, 2, 3, 4, 5, 6, 7. It should be 8. What do we miss? Trapezoid.
Trapezoid, yeah.
Yeah, 5 minutes, perfect.
Okay. Okay.
Now, when you make these cards, make them nice and professional. So you space this stuff out.
Okay.
In other words, this is going to be something you're going to use. You're not just going to make them, but after you make them, you're going to use them, and then you're going to have your mom test you on them.
Yeah, exactly.
Your brother test you on them until you get them down pat so that you know every single thing there is to know about these 8 shapes.
Okay.
And I promise you it will not take that long.
It won't, yeah.
This is the way to go. Whenever you're trying to memorize anything, this is definitely the way to go. I realized
Like,
this summer when I learned that Mullen High School forced the students to do this, I just had forgotten how strong of a learning tool it is, and it's definitely something you want to.
Exactly. You wouldn't think flashcards would be that helpful, but they are.
Yeah, they are, but they're not that common.
They're not,
Because I don't
no.
know that you can go to a geometry store and buy flashcards that do this.
Uh-huh.
And it's better to make your own because the act of making them lodges that information into your brain. It really,
Exactly.
it really
Yes,
does.
it's
So
memory.
it's making them and using them is better than just using them.
And even just like,
Go to the
yeah,
store and buy them, or say your mom made them, wouldn't be as good as if you make them.
no. And like writing it down commits it to memory faster
Yeah,
too.
yeah.
Yeah.
Okay, so on the trapezoid, I'm going to draw this midsection line.
The mid segment.
The mid-segment. So what's the area of the trapezoid?
Would it be, how can we say this?
And I'm going to draw this and call that the height.
Would it be base times height divided by 2, or no?
Close. I've always taught you that it's base 1 times base
Oh, times
height.
base 2. Okay.
So let's label base 1. Let's label base 2.
Okay.
Now we have everything we need. In fact,
Okay.
if we're going to do it like that, I'm going to erase the mid-segment. I don't want it on there.
Okay.
What I was going to say was that if I draw the mid-segment on there, then you can say area is the mid-segment times the height. A little shorter than base 1 plus base 2 divided by 2 times the height. In other words, it's worth knowing what the mid-segment is. It is base 1 plus base 2 divided by 2. It's the average base.
Okay. Cool.
But most of your formulas are this. Base 1 plus base 2 divided by 2 times the height. Okay?
Okay. Okay.
What's a good definition of a trapezoid? What do we know when you say trapezoid? What does it mean?
Well,
Look at that diagram.
yeah.
Tell me what you see. What's the relationship between B1 and B2?
We could, well, B1 is like bigger than B2.
Are they parallel?
Yeah, they are parallel.
That's
yeah. Okay.
The trapezoid's feature is one and only one pair of opposite parallel sides.
Okay.
You can spell parallel out or use that sign if it helps. One and only one pair of opposite parallel sides. In other words, B1 is parallel to B2 always. And the other two sides are not parallel. Notice if the other two sides were parallel, this would be a parallelogram, not a trapezoid.
It would. Yeah,
so
exactly.
you have only one pair of opposite parallel sides.
Perfect.
Now, there's one and only one other thing I can think of about a trapezoid.
Okay.
It has to do with the angles. What can I say about the angles? Doesn't have to do with diagonals.
We could say that they're adjacent.
Adjacent angles are what?
Are supplementary.
There you go.
Okay.
adjacent angles are supplementary.
Okay.
And I don't even know what else you'd want to put on there. Now,
Yeah, maybe.
I didn't think these up before tonight's session. I just thought of the idea. And
That's a good
so
idea,
we
yeah.
may be missing a thing or two on here. So
Okay.
when you make them up, I would leave at least one space, one row at the bottom, maybe even two.
Yeah, sure.
You're gonna have plenty of room, but write big. Don't
Uh-huh.
write tiny. If you're using a 3x5 card, use as much of this space as you can almost.
Okay. So it's kind of like easy to read.
Well, I'm a big believer. You'll notice how big I write when I tutor.
Yeah. Yeah,
I
for
barely
sure.
have enough room to write an equation because I write so large. I've been
Uh-huh.
trying to write smaller for years, but my brain just won't let me do it. And I think it's because I really truly believe inside that the bigger I write, the easier it is to see, the easier it is to understand.
Okay.
And
Yeah, that's
it's going to
a
work
good
for
concept.
you also.
Yeah.
I have some students that write so tiny, they
That's hard for them to
write.
read.
You know why they do it? I figured out why they do it.
Okay.
Because
How do they do it? Or
they're
why? Yeah.
not sure if it's right.
That makes sense. Kind of like a confidence thing.
Yes, that's why
Okay.
they write so tiny, is because they can erase it really quickly and rewrite the correct answer.
That makes
So
sense.
it
Yeah.
is a confidence thing. And
Uh-huh. Okay.
anyway, but I think these are the key properties of these things. And you're going to have to know the properties of these things pretty much for a long time.
Yeah.
This is your basic geometry. And this is only 8 index cards, and you're going
Uh-huh.
to need more because you will get into 3D geometry.
Oh yeah, with like
So,
volume,
yeah,
stuff like
you'll
that.
have volumes and
Mhm.
cylinders and cones and things like that. And you're going to
Yeah.
want an index card for each one. Okay?
Okay.
By the end of geometry, you're liable to have 10 to 20, not 10, you'll have at least 15 to 25 index cards. And
Okay.
you should be proficient looking at
Yeah.
either side.
Okay.
Okay? And
Sounds good.
yeah, I think that's a good plan. I think it's
That is a.
going to work for you too.
I agree. Yeah, that's a really good plan. Awesome.
All right, Dylan. You guys have a good Thanksgiving. I hope you're staying in because it's supposed to snow like heck tomorrow.
Oh man, it's supposed to be only a high of like 25
No,
tomorrow.
and it's snowing all day from the morning.
Exactly. Yeah, you have a good day tomorrow too.
I'm staying in, so I will have a good day. As long as I don't
Awesome.
have to be out driving in it, I'll be happy.
Exactly. Are you having family over? Or?
No, I kind of did a Thanksgiving meal today in place of it.
Awesome.
I
Awesome.
was going to go to my sister's, but not with the snow. Not.
Yeah, for sure. It's kind of dangerous driving it.
Yeah.
Awesome.
All right.
Well, I
Well,
hope
you
you
guys
have a.
have a good meal, and I will
You
talk to
too.
you on Friday, I believe.
Yeah, that sounds good.
Okay.
Awesome. Well, thank you. I appreciate that.
All right, Dylan. Bye bye.
All right.